Okay, so we're starting 2.1 today. Today we're starting with quadratics. Okay, there are two forms of quadratics. You have your polynomial form, which is written in your standard form of decreasing order of degree, ax squared plus bx plus c. Okay, starting with your squared term, ending with your constant. All right, that's your polynomial form. Okay, this is typically the form that we factor, or we do the quadratic formula with, or complete the square with. Okay, then you have standard form. Standard form is your graphing form. It's your vertex form. You might have heard all of those different things when you've talked about standard form. Standard form is where we get all of our transformations from when we have a graph. All right, A, X, and K are your transformations. We talked about this when we did the piecewise functions with the absolute values. All right. A is the slope between the vertex and the first 2 points. It is also your vertical reflection. Positive A values open up, negative A values open down for parabolas. Okay? H is your horizontal shift. Okay, where you go the opposite direction. You always go the opposite direction. Positive for left, negative for right. You always change the sign of H. Okay? And then H is the X value of your vertex. Again, you change the sign for H. K is your vertical shift up or down. Okay? Positive for up, negative for down. And the Y of your vertex. K is the Y of your vertex. You don't change the sign of K. All right, so when you have a graph, you have your axis of symmetry, which is through the vertex. Okay, so the axis of symmetry is x equals h, whatever that h value is in your vertex. That's your axis of symmetry. All right, your vertex is always that middle point. Okay, it's typically your vertex is always going to be your minimum and your maximum. So if you're given a problem and you're asked to find a minimum or a maximum, it's always going to be the vertex of your quadratic. Right? And then you have your guide points. Those are the first 2 points that help guide how wide your parabola is going to open. All right? You don't have to find all the points. You just have to find the first 2. This is what the slope gives you. The slope gives you the first 2 points. All right? So when we graph these, in order to graph them, I need to know 2 things. I need to know my vertex, and I need to know my slope. My slope will tell me if I open up or down, and my slope will tell me how far out and up I need to go. All right, so in my first problem, f of x equals 2 times x minus 1 squared plus 3, what is my vertex? What's my center point? Okay, so I have a -1 and a 3. So that's my h and that's my k. Remember, we always change the sign of h. So it'll be +1 and 3. Because you always change that sign. Okay? So then what is my slope? What is my number that is going to guide how far I open and whether I open up or down? 2. It's that front number. 2. That tells me how far I need to go. Up, down, left, right, all of that. So my slope is 2. Okay, so I'm going to plot my point over 1, up 3. And then my slope is 2. So all slopes have to have a rise and a run. All whole numbers have a denominator of what? 1. So this has a rise of 2 and a run of 1. So I'm going to go up 2, and then left 1 and right 1. Okay? So then my axis of symmetry is there, and my axis of symmetry is x equals 1, because it always equals the h of your vertex. All right, so now we're going to pull in content from chapter 1, and we're going to pull in that domain, range, and end behavior. Okay? That never goes away. So what is the domain of this graph? All real numbers. So you can write the symbol, or you can write infinity to infinity. Negative to positive. All right, what is my range for this graph? What y values do I cover? 3 to infinity. Do I get to include 3? Yes. Okay, your range will always be from that k value and then paired with either negative or positive infinity. Okay, your range will never have any other number in it. It's going to be your k to infinity or negative infinity to k, depending on whether you open up or down. All right, and then my end behavior depends on my ends. So as x approaches negative infinity, what does y approach? As x goes left, y goes up. So I'm approaching positive infinity for both, because both ends are going up. Okay? Questions on that? All right, number 2. Okay, number 2, what is my vertex? -2, -1. Changing the sign of h, leaving k. What is my slope? -1. So that means I'm opening up or down? Down. I'll be opening down. Okay? So -2, -1 with a down slope of 1. So my axis of symmetry is x equals -2. Because it's x equals h. All right, and then my domain. What is my domain? All real numbers. Just put it right on top of my book. Perfect. Thank you. All right, what is my range? I stop there, so negative infinity to -1. Remember, you always go from least to greatest, and negative infinity will always be your smallest number, so negative infinity always has to come first. Positive infinity will always be your biggest number, so that will always come last. All right? So then my end behavior here, both ends go to where? Where do both ends go? Down, right? Both ends are going down, so that means negative infinity. Okay? Questions on that? All right, take a couple minutes and try 3 and 4. Try 3 and 4. Attendance. No Aaliyah today? Oh, okay. No Michaela today. All right, how are we doing? Ready? All right. Okay, so for number 3, what's my vertex? What is it? 0, negative 1. All right, if there is no H or K, it's 0. Okay?
Pass it out third.
Mm-hmm.
Thank you.
All right, so my axis of symmetry is through 0. What's my slope? 1/2. All right, so 0, negative 1 puts me here, with 1/2 being up 1 over 2. All right, so my domain is all real numbers, and my range is -1 to infinity, and my end behavior goes in which direction? Positive, positive. All right, any questions? All right, so for number 4, we're looking at a vertex of what? -1, 2 with a slope of negative 2/3, and an axis of symmetry of negative 1. All right, so my domain is all real numbers, and my range is what? Okay, 2 to negative infinity, or written from least to greatest, negative infinity to 2. And then both ends go down, right? Okay. Questions on graphing? Okay. So next we're going to talk about how to convert from standard form to polynomial form and from polynomial form to standard form. Okay? All right, so to convert, it is as simple as expanding the binomial and then combining like terms. Okay, so expanding the squared and then combining like terms. Remember, when you expand the squared and you have x minus 1 squared, you do not get to distribute that square in. It is not x squared minus plus 1. Okay? Remember, you have to FOIL it out. Okay, that x minus 1 is the same as x minus 1 times x minus 1. Okay, so you can do the shortcut, square, double square. Or if you need to see it FOILed out, FOIL it out. All right? Yes?
So isn't it already in standard form? 'Cause that's...
Well, okay, yeah, sorry. From convert. Thank you. We're putting it into polynomial form. My bad, thank you. Okay, so this should show you, you're taking care of the exponent first, right? Follow the order of operations. Exponent first, and then you go from there. Okay, so now you can multiply in any order that you want once you expand that exponent. Now, I would say that if you can, do the shortcut for squaring a binomial and square a double square. Okay, if that still doesn't connect for you, then distribute combine like terms. Okay? And then you have to distribute the 2 into the parentheses. And then combine like terms. Okay? Questions? Expand the square, FOIL it out. So I did x to x, x to 1, 1 to x, and 1 to 1. I combined like terms, distributed the 2 in, and then combined like terms there. Okay? Questions on converting from standard to polynomial? Huh?
It's pretty straightforward.
It's just some algebra. All right. All right, let's do the second one. So the negative stays outside until after you square double square. So x squared, 2x doubled is 4x, plus 2 squared is 4. Okay. Distribute the negative. Combine like terms. All right, you guys try number 3. You guys done? Okay. So squared, right? Square the binomial, distribute the number in, combine like terms. Okay? Any questions on that? All right. we're going to stop here for today, so we leave off at the same place the other class left off. Tomorrow we will convert the other way, which involves completing the square. And then we'll graph it in both forms. Okay?